All right, so in the last section, section 1.5, we talked about integer exponents. In section 1.6, we're going to be talking about rational exponents. So this is when you have an exponent that's a fraction. We have two properties that we need to look at here. If we have a to the 1 over n, that can be written as the nth root of a. Now, we've seen the radical before. We see that as a square root, right? But you can have numbers in the crook. We call that the index, and that changes what the root is. We also have a to the m over n. That can be rewritten as the nth root of a raised to the m power. So basically what happens is it becomes a radical. Your denominator becomes your index, and your numerator becomes your exponent. We're going to start off with the square root of 25. If we do not see an index, we can imply that it's a 2, so it's the square root. So we're looking for a number that multiplies by itself 2 times to get to 25. Well, the square root of 25 is 5. Let's move on to the next example. We have 27 to the 1/3. This can be written as the cube root of 27. So you're looking for a number that multiplies by itself 3 times to get to 27. Well, we can start off with 1 times 1 times 1, that's just 1. 2 times 2 times 2 gives us 8. 3 times 3 is 9. 9 times 3 is 27. So that's what we're looking for. So the cube root of 27 is 3. Now let's move on to 9 to the 3 halves. This is one that we're going to need to rewrite using the second property here. This is going to be the square root of 9 raised to the 3rd power. Let's simplify the inside first. The square root of 9 is 3. And 3 cubed is 27. Now let's look at some problems with variables in them. We have x to the 1/4 times x to the 1/3. Now, these are rational exponents, but we don't need to change anything. We can go back and use those properties of exponents in the last section to solve this problem. If you have two numbers that are multiplied together with the same base, we can add the exponents. So let's add 1/4 plus 1/3. Well, when we're adding fractions, we have to find a common denominator. The common denominator for 4 and 3 is 12. That's going to give us 3/12 plus 4/12. And so we add those together to get 7/12. So our answer is x to the 7/12. Let's look at example E now. We have c to the 4/3 raised to the 5/6. If we have an exponent raised to another exponent, we can multiply those together. So we can multiply these two fractions. We just multiply across the top and across the bottom. 4 times 5 gives us 20. 3 times 6 gives us 18. We can reduce that though, right? So that's going to give us c to the 10 over 9. All right, so c to the 10/9. In example F, we're looking at the 4th root. We have the 4th root of 81, m to the 12th, n to the 20th. So just like with the numbers before, we're looking for a number that multiplies by itself 4 times to get to 81. In this case, it's going to be 3. In order to solve the variables though, there's a neat trick that we can use. We're just going to divide. So we're going to say, how many times does 4 go into 12? Or what is 12 divided by 4? It's going to be 3. So that means this is going to be m to the 3rd. How many times does 4 go into 20? It's 5, so that's going to be n to the 5th. And that's our answer there. With example G, this is like that long example that we had in the last section. We're going to have to work this in steps, and we're going to start on the inside. So let's reduce the inside as much as possible. We have t to the 6th, u to the -3rd over t squared, u to the 9th, and all of that is raised to the 5/4. Let's reduce our t's first. We have t to the 6th over t to the 2nd. Since they have the same base and they're divided, we can subtract. The 6 is bigger, so that's going to leave us with t to the 4th on top. With our u's, we have u to the -3rd and we have u to the 9th. 9 is bigger than -3, so we're going to do 9 minus -3. Once again, that's minus a negative. It becomes 9 plus 3, and that's going to give us u to the 12th. All of that is in parentheses and raised to the 5/4 power. So now we're going to distribute that 5/4 to both of these. That's going to give us t to the 4th to the 5/4 and u to the 12th to the 5/4. We can put these whole numbers over 1 and now we can multiply together. We can cross cancel if we want to beforehand. That's going to give us a 1 and a 1 there. So that's going to be t to the 5th right here. That's going to be a 3 and a 1. And that's going to be over u to the 5th. So our final answer is t to the 5th over u to the 5th. This is the end of chapter 1. Don't forget to reach out to your instructors if you have any further questions. And we'll see you around for chapter 2. Thanks. Bye.